In our next few examples, we'll switch things around. Let's say we need to figure out how much to make or deposit regularly into an account in order to achieve certain future values. So maybe you have some goals that you want to achieve for something in the future, whether it's retirement or sending your child to college, or if you're a company, maybe you have a project you have in mind in the future. So if you know what your goal is, your monetary goal, we can actually work out what your payment needs to be using a very similar payment formula that we worked with loans. In fact, it's exactly the same payment formula. That PMT formula that we worked with loans, we'll start with an entry, which is the rate. Now, that always has to be the rate based on the compounding period or how often you're making payments. So that would be the rate as an interest as a decimal divided by n, which is the number of times you put payments in during the year. And then our number of periods is representing how many payments you make total in that period of time you're looking at. So that would be n times t. Then we have present value and future value. We had present value and future value with loans. Present value, I want to remind you, is always your starting value. Now with loans, our starting value was the amount of the loan. And in the future, we went down to how much we would want to owe at the end, which was 0. But when we're thinking about investing and saving up for the future, this future amount would actually be our goal. Our starting amount would probably be 0, start with nothing, and our goal would be, our future value would be that goal of how much money we want in the future. So we kind of use the same formula, but we kind of switch those two numbers around in terms of present value becomes the low number, future value becomes the high number. With loans, you start with a high number to pay it down to 0 at the end. So again, starting value in this case with investments is going to be a lower number. Let's look at two examples of this. Let's say you want to have $80,000 in a college savings fund for your child after 18 years. How much would you need to deposit each month to achieve this if the college savings fund earns 4.5% compounded monthly? Well, let's use this payment formula. Start with an equals PMT for payment. We're going to enter in our rate, but it has to be the rate based on how we're depositing the money and earning interest on it. So we're earning interest monthly. So we're going to make this rate, change the yearly rate of 0.045, change it to monthly by dividing by 12. Then we look at the total number of payments we're going to put in, or deposits. That would be 12 times a year over the course of 18 years. So I say 12 times 18. Then we put in our starting amount. Now it doesn't say we start with any particular amount, so let's assume 0. That's what you'd always want to do if it doesn't say that you're starting with something. And our future goal or a future value would be that we want to have $80,000. That's our goal over the course of these 18 years. Now when you put in 80,000, be really careful. With big numbers like this, it is tempting to put a comma in that 80,000. Do not. If you do, the spreadsheet will give you the wrong result. Likewise, it's always a good idea to check your decimals. Make sure before you hit enter that you've put those decimals in correctly. All right, so here's a screenshot from when I did this in Google Sheets. And you can see I put in the formula just as I had written it here, and I get negative 241.06. Ignore the negative again. This is telling me that my monthly deposit needs to be $241.06 per month to achieve that goal of $80,000. That will get me to $80,000 in 18 years if I very carefully put that much money in each month. All right, let's do one more example. Say your company needs $2 million for an expansion project in 6 years. How much should be deposited quarterly in an account that earns 8.3% interest compounded quarterly? Now, in most of our examples, we've been talking about individuals saving up. And so most people tend to think monthly because that's how we pay most of our bills, and we also earn money on a monthly basis. With companies, that may be a little bit different. Sometimes companies are more likely to do things on a quarterly basis or even semi-annual or annual basis. In this case, I have changed this and I've got the company depositing quarterly, and we're going to make sure they earn money the same way just to make it easier. So they're going to earn that money on or interest on that quarterly as well. So be careful. Every once in a while you may get a slightly different example where it's not monthly, but in this case it's quarterly. So we need to work out the payment to achieve this goal. So start with equals in your spreadsheet, PMT. We have an interest rate that we're earning on this money of 0.083. That's the annual rate, so we need to divide it by 4 to represent that we're earning interest quarterly. So again, quarterly here, change that to a 4 instead of 12. Sometimes we get into the habit of just automatically doing 12 because that's more common for an individual person. Now, how often we put money in is going to be on a quarterly basis, so it's going to be 4 times a year for 6 years. So I'm going to say 4 times 6. Technically, that's 24 times. Next, we will put in the starting amount. Again, it doesn't say we're starting with any particular amount, so let's say that's starting with 0. And then the future goal is that $2 million. Again, be really careful not to put in any commas, and double and even triple check that you put the right number of zeros in. All it takes is one of those zeros left out or one too many and everything's wrong. So check your decimals, check your zeros before you hit enter. Here's the screenshot from when I did this in Google Sheets. And you'll see that the output ends up being $65,142.72. So this company needs to put that amount of money, $65,142.72 per quarter, into this investment to achieve $2 million after 6 years. Now, if you work this out, $65,000 seems like an awful lot to put down per quarter, but remember this is a company, not an individual. And you might say that's still a lot to put aside, but if you work that out, putting that amount of money in 4 times a year over 6 years, your deposits come out to be just over $1.5 million. What that means is this company over 6 years is earning almost $500,000 in interest because they're taking advantage of compound interest. They're putting money aside slowly over time, because maybe they can't afford $2 million all at once, but they can put in a lesser amount as long as they're doing it on a regular basis and actually end up earning, like I said, almost a quarter of what they need in interest within 6 years.